Okay, so now we're looking at a graph and we're going to write the system of inequalities represented by the graph. Number 1 is going to be slightly different than number 2. Let's get started. So let's look at the solid line first for number 1. Well, my y-intercept is 1. My slope is up 1 and over 2, so my slope is 1/2. So right now I have y is equal to a 1/2 x plus 1. But remember, we're not writing an equation because this is a system of inequalities. So I am going to change the equal to sign. And since it's a solid line, there will be an equal to sign within my inequality. And since the shading is below this red line here, then that would mean that this is a less than or equal to 1/2 x plus 1. So that's my first inequality. My second inequality, I'm going to write in blue, and that's going to be the dotted line. My y-intercept of my dotted line is also 1, and my slope is up 1 and over -2, so it's a -1/2 x plus 1. Since it's a dotted line, there will be no equal to symbol within my inequality. And looking at this line, it looks like I shaded below this line as well, so it would be a less than symbol. So this is my system. That's it. Now, I want to determine if the point 0, 1 is a solution to this system. Well, that's this yellow dot here. And since it falls on the dotted line of my blue inequality, then this would not be a solution to the system because it would not satisfy the blue inequality. It would satisfy the red inequality, but not the blue one. And if you wanted to check, you can put 0 in for x and 1 in for y in both inequalities, doing my red inequality right now. I wind up with a 1 is less than or equal to 1, which is a true statement. It works in my red inequality. But if I did my blue inequality right now, I put 1 in for y and 0 in for x. I would wind up with 1 is less than 1, which is not a true statement, so it doesn't work in the blue inequality. So no, this isn't a solution to the system. All right. Now number 2 is slightly different because we're gonna write our system. However, if I'm gonna highlight this line in red. That line, the y-intercept, is we cannot estimate, but it doesn't go exactly through a whole number. So we're gonna actually have to do some work on this. And so I'm going to use the 2 points on this red line that I have highlighted, which are the points -4, 1. I'm going to label that x1, y1. And I'm going to label the point 2, -1, x2, y2. Now I'm going to go through the process of finding the slope and then writing my equation in slope-intercept form and then changing it into an inequality. So my slope formula for my red line would be y2, which is -1, minus y1, which is 1, all over x2, which is 2, minus x1, which is -4. So minus a -4 is really a +4. So I wind up with a -2 over 6, which reduces to a slope of -1/3. Now I'm going to write an equation in point slope form using my slope and using one of the red points. It does not matter which one. I'm going to use this one here, the 2, -1, and I'm going to write my equation as y minus the y value of that point. Y minus a -1 is really a +1, is equal to my slope times x minus the x value of that point, which is 2. Now I'm going to convert this into slope-intercept form. Isolating y by subtracting 1. I wind up with y is equal to a negative 1/3 x, and then a 2/3 minus a 1. 1 can be written as a 3/3, so a 2/3 minus a 3/3 is a negative 1/3. So this would be the equation, but this is not an equation. This is an inequality. It's a dotted line, so that means that I'm gonna change my equals sign, and my inequality symbol is not going to have an equal to symbol in there since it's a dotted line. And the double shaded region is right here, so that actually lies below this red dotted line. So it will be a less than symbol. This is one of the two inequalities. Now I'm going to work with the other dotted line, which I'm highlighting in blue. This blue dotted line does not intersect the y-axis at a whole point, and we cannot estimate what the y-intercept is. I guarantee you probably did not guess the y-intercept was negative 1/3 for my red equation, or my red inequality. So we cannot estimate for my blue either. But I'm going to do the same process. I'm going to use these two blue points. My first blue point I'm labeling x1, y1. My second blue point I'm labeling x2, y2. And I'm going to go through the same process as I did for the red inequality to find my blue inequality. I'm going to use slope. Slope is y2, which in this case is negative 3, minus y1, which is 2, all over x2, which is 3, minus x1, which is negative 4. Minus a negative 4 is the same as a plus 4. So I wind up with negative 5/7 as my slope. So I'm going to use this negative 5/7, and one of the blue points, it does not matter which one, I'm going to use this one here to write my equation in point slope form. So I have a y minus the y value, which is a negative 3, so it's really a y plus a 3, and that will equal a negative 5/7 times x minus the x value, which is 3. Now I'm going to transform this into slope-intercept form. And I wind up with y is equal to a negative 5/7 x, and then a 15/7 minus a 3. I am going to need to convert the 3 to have a denominator of 7. So a 3 with a denominator of 7 is really a 21/7, because a 21 divided by a 7 is a 3. So a 15/7 minus a 21/7 is a negative 6/7. And so now I'm not going to leave this as an equation because this is an inequality on the graph. So I'm going to erase my equal to sign, and now I'm going to work to figure out what type of symbol I'm going to have as my inequality symbol. Well, this is a dotted line, so I will have no equal to sign in my inequality. And this is the blue line we were working with. The double shaded region is this part right here, which lies above your line, so that would be a greater than symbol. This is your second inequality in the system of inequalities, and I guarantee you did not estimate that the y-intercept was at negative 6/7. There's no way you could have guessed that. So these two inequalities create your system for this graph. All right, and that is it for this lesson.